Hi guys, this is Krishna Madhur.
So we'll find the Laplace transform of function f of t equals to sine 2t. Yeah. Now we know that the Laplace of any function is defined as integral 0 to infinity e power minus st into f of t dt. So substituting f of t as sine 2t, we get Laplace of sine 2t equals to 0 to infinity e power minus st into sine 2t dt. Now using integration by parts, we'll find the integral of this, which implies for now let's assume that these functions are indefinite, as in let's not consider the limits and solve it. At the end we will apply the limits and then find the final answer. uh, yeah, so let's just simplify this first. So yeah. Here we have another term that needs to be as in we'll have to apply the integration by parts again for this term and find the uh, final answer. So what we do is we'll take this, we'll consider this as equation 1 and then find the integral of this separately, which is integral of 0 to infinity cos 2t e power minus st dt using integration by parts. Because it's minus sine 2t. Simplifying this, minus 2 by s, minus is because of this, integral 0 to infinity e power minus st. Now this is our question which we were which was our aim to solve in the beginning. This one, this. So firstly, substituting this equation 2 and this as the question Laplace of sine 2t, we get Laplace of sine 2t equals to minus 1 by s e power minus st sine 2t, this one, plus 2 by s, this has been solved, minus 1 by s e power minus st cos 2t minus 2 by s into Laplace of sine 2t. We now further simplify this. As I said previously, we have considered these as indefinite integrals as of now, and hence we have not applied the limits. Now let's take this term to the LHS. We will have Laplace of sine 2t multiplied with 1 plus 4 by s square, which is equals to minus st by s sine 2t minus st by cos 2t. Now, in order to apply the integrals, or we have to apply the integrals only to the terms wherein we have the variable t. So we now apply integration to this, which imply not integration, limits. So we get e power minus st by s sine 2t 0 to infinity minus 2 e power minus st by s square cos 2t 0 to infinity, taking 1 by s outside. Now the applying infinity here, substituting infinity in place of t, we get 0, and yeah, as well as we get 0 here for this term, and substituting 0 again in place of t, we get sine term as 0, this, and let's take 2 by s square common here, outside here, and then applying infinity is going to give this term as 0. Applying 0 will give this term as 1, and cos 0 as 1. We will get the answer as plus 2 by s square. Now these both are equal, like that's what we have solved. So we now imply these both, equate these both. So we have Laplace of sine 2t equals to 2 by s square into this is nothing but s square plus 4 by s square. So taking this term to the RHS, we have s square by 4 plus s square. S square and s square gets cancelled, which implies Laplace of sine 2t equals to 2 by 4 plus s square. Thank you.